In previous lecture, we talked about the basic quantities and also the passive sign. If the voltage and current satisfies the passive sign convention, we can discuss the element is supplying or absorbing the power. When the power is positive, it is absorbing power. When the power is negative, it is supplying power. And in this lecture, we will talk about the basic elements, that is the passive elements and active elements. And we also talk about the active sign convention. Let's start today's lecture. This is chapter 1.3, circuit elements. The circuit elements can be classified into passive elements and active elements based on whether this element can generate energy. Of course, the resistor, as we discussed in the previous lectures, it cannot generate energy, so it's passive elements. And there are another two types of passive elements, that is the capacitor and inductor. We will talk about them in chapter 6. And also here, some passive elements are capable of storing energy. That is the capacitor and the inductor, they can store energy, but the resistor cannot store energy. For the active elements, it refers to the power sources which can generate energy, and it has the voltage source and current source. First, let's take a look at the independent voltage source and independent current source. So for the independent voltage source, it maintains a specified voltage across its terminals. So this is independent, so the voltage is not related to other quantities. So the voltage across the ideal voltage source is independent of all other elements that are connected to it and of the current flowing through it. And depends on whether it is DC voltage or AC voltage, we use different labels. And also, in some simulation software and in some other textbook, they use this symbol to denote the voltage source, DC voltage source. For the independent current source, it forces a specified current to flow through it itself, and it is independent of all other elements. So we have the symbol for current source, the DC current source and the AC current source. This figure shows the VI plot. V is the voltage, I is the current. These plots are very common in our textbook. For example, for figure A is the independent voltage source. We can see that the voltage keeps a constant. The voltage is a constant no matter the current is large or small. If the current is large, the voltage is a constant, and if the current is small, the voltage is the same. So that's why we call it independent voltage source. So it keeps the voltage a constant value no matter how large or how small the current is. The second figure shows the independent current source. In this scenario, its current keeps a constant no matter how large, how small the voltage is. The current is independent, is a fixed value. And in previous lecture, we talked about the passive sign convention. Do you remember the passive sign convention? For an element, right, the current flowing through the positive terminal, and if the power is greater than 0, it is absorbing the power. If if the power is a negative, it is supplying power. This is the passive sign convention. And usually the passive sign convention is used for passive elements. And here we introduce the active sign convention. It is opposite to the passive sign convention. Here we can see that the direction of the reference direction for the current is flowing out of the positive terminal. It's opposite to the passive sign convention. And so in this scenario, for the active sign convention, if the power is a positive value, it means it is generating the power. If P is negative, it is absorbing the power. So it is opposite of the passive sign convention. And this active sign convention is usually used in power supplies. That is the voltage source or current source. Okay, let's give you an example that is determine the power absorbed or supplied by the element in the network. For this network, we can see that there's one voltage source, 24 volts, right? And there are two elements. So for element 1, we can see that it satisfies the passive sign convention. So that is P1. So that is P1 for element 1 equals 2 times 6 equals 12 watt. It is absorbed. For P2, it also satisfies the passive sign convention. 2 times 18 equals 36. It is also absorbed. And for the voltage source, PV voltage source, we can see that it satisfies the active sign convention, right? The reference direction of the current is flowing out of the positive terminal. So the power is 24 times 2 equals 48. It's a positive value, but it is active sign convention, so that is supplying the power. So the power absorbed by element 1 and element 2 equals, the sum is 48 watt. This is absorbed. And the power supplied by the voltage source is also 42 watt. So this is the power absorbed by the elements equals the power supplied by the source. And let's take a look at another example. This is from, I think it's from Alexander's textbook. For the element 1, we can see that it satisfies the passive sign convention. So it is 3 times 18 equals 54 watt. It is absorbed. For element 2, it does not satisfy the passive sign convention, right? So we change the reference direction for the voltage. So the voltage becomes negative 6 volts, right? So the power absorbed by the element 2 equals 3 times negative 6. It is negative 8. It's negative 18 watt. So it is absorbed or negative power. So the actual it is supplying the power. It is supplying 18 watt supply. And for the current source, it satisfies the active sign convention. So that is, it is supplying 36 watt. It is supplying. So we can see that the supply is 36 plus 18 it equals the absorbed power. So we just introduced the independent sources, and next we will introduce we just introduced the independent sources. Next we will introduce dependent sources. So the dependent sources generate a voltage or current that is determined by a voltage or current at a specified location in the circuit, and we use a diamond to represent dependent sources. So it can be classified. There are four types: voltage controlled voltage source, voltage controlled current source, voltage current controlled voltage source, and current controlled current source. We can see figure A shows the voltage controlled voltage source. We use a diamond to represent it. So the voltage V equals mu times Vs. So the value of V is determined by Vs. So that is the Vs controlled the voltage of the voltage source. And the figure B is a current controlled voltage source. So the V equals R times Is. So it depends on the value of Is, we can calculate the value of V. Figure C is the voltage controlled current source. So the current I equals G times Vs. Depends on how large or how small the Vs is, we can calculate the current I. And the figure D is the current controlled current source. So the current I depends on the value of Is. Okay, let's take a look at this example that is use Telegans theorem to find the current I0. We can write down the power absorbed by the passive element and the power supplied by the active element, and write down the equation. First, let's take a look at the passive element. Passive element, there are three passive elements: element 1, element 2, and element 3. For element 1, it satisfies the passive sign convention, so that is the power is I0 times 6 equals 6I0. For element 2, it does not match the passive sign convention, so we can reverse the direction of the current. So the 9 ampere becomes negative 9. So that is negative 9 times 12, which equals negative 108. And for element 3, it also does not satisfy the passive sign convention, so that is P3 equals negative 3 times 10 equals negative 30. That's the power absorbed by the passive elements. How about the active element? We have the one independent current source, one independent voltage source, and one dependent voltage source. So let's calculate that. For the current source, PC equals, we can see that it satisfies the active sign convention, right? So the voltage is 6 volts and the current is 2 ampere. So 6 times 2 equals 12. For the voltage, for the independent voltage source, it also satisfies the active sign convention. So PV equals 8 times 4 equals 32. And for the independent source, for the dependent voltage source, the current and the voltage, it does not satisfy the active sign convention, so reverse the reference direction for the current. So 11 ampere becomes negative 11, and the voltage is 8 times Ix. We know Ix. So the voltage of the dependent source relies on Ix. We know Ix equals 2. So we can calculate 8 times Ix, that is 16. So that is also PV, let's call it PV controlled, equals -11 times 8 times 2. This equals -126. So we can write down the equation, that is the power absorbed by the passive element equals the power supplied by the active component. So that is 6 times I0 minus 108 minus 30 equals 12 plus 32 minus 176. By solving this equation, we can obtain that I0 equals 1. So in the previous slides, we talked about the ideal elements, but in reality, there are no ideal elements. The wires have resistance. The voltage sources are affected by elements connected to them. So this is the real-world model representation of the voltage source. It has a resistor in series with the voltage source. For the real-world representation of a current source, we have a resistor in parallel with the current source. So this is a real-world representation of the voltage source. So we have additional examples and in Alexander's book. So this is a summary of chapter 1. We talk about the standard prefixes. We talk about the relationship between current and charge, and the relationship among power, energy, current, and voltage. You need to remember P equals V times I. And we also talk about the passive sign convention for passive component. And we also talk about the active sign convention for active component. We talk about the independent and the dependent sources. And we also talk about the conservation of energy. That is the Telegrams theorem, how to apply Telegrams theorem in our circuit. So that's the end of chapter 1. Thank you.